Their topic is quantum computing in retail industry today and tomorrow. Let's give a warm welcome to Mr. Poon Ching Chong, Director of Tsang, and Dr. Tsang, Senior Quantum Scientist, Qubit Science Limited.
Hello everybody, this is C.C. Poon from Tsang Technology Limited. We have been in the LED markets for 20 years. About like some 10 years ago, I met my university schoolmates on the street, and then we chat and then like a few years ago, he came to me and said, okay, we want to do something new. And then that's the quantum computing. And somehow we met another schoolmate in the university a few years ago, and this is Dr. Tsang. And so with another schoolmates, the four of us then started to work on quantum computing. And now we are starting a company called Qubit Science to work on this technology. May I now ask Dr. Tsang to give a presentation today. Dr. Tsang.
Thank you very much. We are Qubit Science, a startup in quantum computing application. Thank you very much. Welcome to the Convention Center today to hear my talk. Why should you concern yourself with quantum computing today? Why should you pay attention to quantum computing as of now? The reason is very simple. It is because of the availability of QaaS, Quantum as a Service. Quantum as a service is basically some big company putting their quantum hardware on the cloud, and you can rent their service at a very reasonable price. Who are providing quantum as a service now? You can see that Amazon is providing it via Bracket, IBM is doing it, Microsoft is doing it via their Azure quantum service. If I say that quantum computing is going to revolutionize the retail industry, you do not need to believe me. If I say that quantum computing is going to be vitally important in the next 5 to 10 years, you don't have to believe me. But look at who is doing quantum computing now. Amazon, Microsoft, Google, IBM. They are starting departments. They are investing billions of dollars. They are giving you quantum as a service now, and you can use it today. We are very confident that quantum as a service will grow rapidly in the coming future. Why? The reason is this. Look at this diagram. The red quantum as a service is available nowadays, and this is driving market demand, which in turn drives the coming of startups to invest in better quantum hardware. With better quantum hardware, there will be better quantum as a service. And with this, once again, the market demand will pick up. This is going to be a virtuous cycle. Now, I have been talking about quantum computing. And what is quantum computing? To explain quantum computing, I need to say a little bit about our conventional computer. The conventional computer we have today is based on the bit. And the bit is basically either the number 0 or the number 1. You can string the bits together to form a bigger number. For example, if you put 1, 0, 1 together, it can represent the number 5. This is the basis of our conventional computer. Now, how about the quantum computer? The quantum computer is also based on a bit. It is called the quantum bit. A quantum bit can be a 0 or a 1, but what is the most amazing thing is that it can be a superposition of 0 and 1. We have here, in the second formula, in the second equation, a quantum bit we call Tsang, and psi is the superposition of 0 and 1. When you measure psi, it will either be 0 or 1, with the probability of 0 or 1 determined by the value of alpha and beta. You do not need to understand this to use quantum computer, but this equation is the basis of why quantum computing is important. Similarly, you can string together the quantum bits to form a quantum register. For example, if you string together 4 quantum bits, Q1, Q2, Q3, Q4, to form a quantum register, you have 2 to the power of 4, 16 possible 4-bit binary numbers. And that would mean 16 computations at the same time, which can also be entangled. If you have a better hardware and string together 64 quantum qubits, Q1, Q2 up to Q64, you have roughly 1.84 times 10 to the 19th power of classical computations that can be carried out at the same time, which can also influence each other. Here you can see why quantum computing has an edge over conventional computing. This is where quantum supremacy comes in. We are saying quantum supremacy because quantum computers has an advantage over conventional computer that is very significant. It is not based on parallel computing. It is more than quantum computing because the calculations can influence each other via quantum properties. In addition, the result of the quantum calculation is probabilistic. This means that if you run the same computation 5 times with the same input, you can get 2 different results, and each will be near the optimum solution. Quantum computers are so much better than conventional computers, but what can you actually get today as of now? At this moment, what you can get is NISQ, Noisy Intermediate Scale Quantum Computers. What does that mean? I will give you an example. At today, Amazon's QaaS Quantum as a Service, they provide a 32 qubits quantum computer for you to rent. And it is very noisy. A noisy computer means that it has errors that need to do some post-processing. And also, there are restrictions in the way you can use the quantum computer. Next, you may ask, what is a quantum computer good for? What can I use it for, especially in the retail industry? I will give you several examples. For example, you can use a quantum computer to find the optimal product mix or the product portfolio that you can provide in a shop. In a small shop, that is not a problem, but in a big supermarket, for example, finding the optimal product mix is a genuine problem that can lead to significantly better profits. Another example is the finding of the store locations. Imagine you can have hundreds of shops in the Hong Kong area. Where are you going to put your shops? You can optimize that arrangement using quantum computers. Another example is the allocation of shelf space. Assume you have many shelves. how are you going to select the products to put on the shelves? And where do you put them? You can use a quantum computer to optimize that solution. My final example is the route planning for delivery. Suppose you have a lot of things to deliver. How are you going to plan your delivery route? You can use a quantum computer to optimize that solution. Are there anybody using quantum computers now? Yes, there are. I will give you two examples. The first example is Save on Foods from Canada. They have turned a computer task that took 24 hours into a 2-minute one using a quantum computer. For a bigger problem, we have Volkswagen of Germany using quantum computer for a pilot project in Lisbon, the capital of Portugal, for traffic optimization. Now I'm going to show you an example of actually running a quantum computer and comparing it to the performance of a conventional computer. To illustrate my example, I will use the knapsack problem. What is the knapsack problem? In the knapsack problem, you have a knapsack, a bag, that can hold a certain weight. And now you are given a collection of objects with different weights and different costs. You want to maximize the costs of your selection in the bag, but without exceeding the weight limit of the bag. When you have a small selection of objects, say 7, a quantum computer takes 2.6 seconds to give you the answer. The conventional computer needs 0.025 seconds to come up with the answer. When you have 60 objects to select from, the quantum computer takes 2.52 seconds, and the conventional computer takes 0.794 seconds. If we up the ante and have 653, 10 times, almost 10 times the number of objects, the quantum computer takes 3.38 seconds, and the conventional computer takes almost a minute. Now when you really go for broke and have 3,338 objects, the quantum computer takes 9.95 seconds, and the conventional computer takes 17 minutes. You can say, I can use a better computer, a better conventional computer, upgrade my hardware, buy a faster processor or more RAM. But if you have keep up yourself with the news of the chip industry, you will know that the computer chip is nearing its performance limit. And also, if you carefully examine the performance of the conventional computer, you can see that as the number of objects increases, the time for coming up with a solution increases exponentially. This is the reality of the quantum supremacy. You can say, how can a company get started in the quantum computing area? What would you need to do if you want to get into quantum computing from ground zero? Well, the first thing you have to do is to figure out quantum algorithms, which requires a lot of deep mathematics and quantum physics. The next thing you have to do is to learn quantum circuit programming. And here you need the help of an expert quantum circuit engineer. Finally, you need to map your real-life problem into a form that is accessible to quantum computers. Or instead of doing all that, you can work with Qubit Sci Limited. We will provide you with a shortcut to the quantum computing solution. Our conclusions are these. Quantum hardware is evolving rapidly. If this is the first time you hear about quantum computers, in the next 5 to 10 years, they will be revolutionizing your industry. Quantum software is evolving rapidly as well. It is getting better and better at solving real-life problems. What you need to do now is to prepare for the quantum advantage. Now, prepare for quantum advantage. Thank you very much. If you would like to know further, you can check out our website, qubitsci.com, or send us an email. Thank you very much.